The UScan facility was recently installed at the Burn Road, Foodtown location. The store manager would like to know if the mean checkout time using the standard checkout method is longer than using the UScan method. She gathered the following sample information listed below in the chart. The time is measured from when the customer enters the line until their bags are in the cart. Hence, the time includes both waiting in line time and the checking out time, and the alpha level of significance that we'll be using is the 0.01. So let's go ahead and put that in right away, so we don't have to worry about that again. Looking at our underlined areas here, we see that the mean checkout time is longer than is what we're looking for, so we know it's not going to be just a difference for our null hypothesis, but it's actually going to be a greater than or less than and equality as well. So we have our null statement right here, that is that the mu sub s, or the standard method, is less than or equal to the mu of the UScan method, and the alternate is that the mu sub s, or the standard method, is greater than or greater than the mu sub UScan method. So based on this, looking at our alternate, we can see that our rejection region is going to be on the right hand side of our distribution. Let's start filling in some information that we have. Looking at our formula over here, we have the x bar sub s, so we want to get the mean of the standard method, which is over here, 5.5, and we're going to subtract it from the mean of the UScan method, which is 5.3. And here, inside of the square root symbol, we have the variance of the standard method divided by the n, or the sample size of the standard method, plus the variance of the UScan method divided by the variance of the sample size of the UScan method. So what we can do here is put in that this is going to be 0.40 times 0.40, which is the square of the standard deviation, because we're given the standard deviation, not the variance. The n we are given, that's 50. And just to fill it in, since we're here, the n of the UScan method is 100. And up here, we'll do the 0.30 times 0.30. Now, to do the formula to the next level, we'll just do the numerator and solve for that. And then we'll solve for the denominator, which has quite a bunch of parentheses in there, and I'll try to make sure I get them all. But just to show our work, we're going to do our 0.4 times 0.4 to show our squaring, and then we're going to divide that by 50, our sample size for the standard method. Close out the parentheses. Then we're going to add that to our calculation for the UScan method. So we have our 0.30 times 0.30 divided by 100. Close out the parentheses and then close it out once more, and our calculation brings us 0.064031, and if we expand that out, that would show up even more. Bunch of numbers in there. Then all we have to do in the final step is just to divide. Now, certainly we could do all of this in just one calculation right here if we choose to do that, but I wanted to illustrate what it looks like a little bit more with the numbers put in the right place. Maybe it'll help you understand it better. It helps me. So now our critical value, what we need to find is the rejection region, which is the end of the probability distribution. So what we need to do is take 0.5 minus our alpha significance level, which is 0.01. We find 0.49 in the back of our book in the appendix, and we find that the value for 0.49, the z value that we get, is 2.33. If we go back and think about what is our rejection criteria, the rejection criteria is that we'll reject the null if the z statistic is greater than the z critical value. So we have our z critical value, which we can just go ahead and put into our formula or our statement here. And we have our z statistic, which is 3.12, and so on. We'll leave it at 3.12. So based on that, if our rejection criteria is reject HO, or our decision rule is reject the null if the z-stat is greater than the z critical value, and we can see what those two values are, we know we can go in here then and we can say we do reject the null hypothesis because the z statistic 3.12 is greater than z statistic, or the critical value of 2.33. We conclude that the USCAN method is statistically faster than the standard method.